Hi friends, welcome to my channel. This is Sayed Reshma. In this video, we are going to discuss about the transformers, construction of transformers. There are two basic parts of transformers. First one is magnetic core and another one is windings or coils. So in this transformer, the core is like this. What is the job of this core? This core provides a path for magnetic flux. Okay, this is the core. Here this is a limb and inner part it is yoke. The maximum flux passing through the maximum flux which is passing through this core, the two losses occurs in this core. Those losses are hysteresis losses and eddy current losses. See, let's discuss about these both losses. These both losses together called as iron losses or magnetic losses. So now we need to construct a core to make sure that in such a way that the both losses are very less. If losses are more means it is a little bit useless. If losses are less means the material is very good material. Our concept is that we have to decrease as much as possible these losses. Let's discuss about hysteresis losses. Generally, the core is made up of high-grade silicon. High-grade silicon steel. It is high permeability material. Earlier, the core is made up of iron. In previous days, this core is made up of iron. But nowadays, due to some advancement in material sciences, we are going to use high permeability material, that is high grade silicon. Why we need this high grade silicon material? Let's discuss. Why we need this high permeability material? In order to reduce hysteresis losses. Are reduced by using high permeability material. Next, we go for eddy current losses. In case we have to reduce these current losses. So the core is made up of a thin laminations. In order to reduce this eddy current losses, we have to minimize eddy current losses by using very, very thin laminations. In order to reduce eddy current losses, because eddy current losses happens because of high width material. If the material width is very high, automatically the eddy current losses are more. So, in order to reduce these eddy current losses, we have to take very thin laminations. What we are doing here, we are providing thin lamination that is of 0.5 or 0.7 mm, so that the width we have very, very less. Now these thin laminations we can put one over the other to form a strip. One over the other to form a strip, and these laminations are insulated from each other by insulation called as varnish. This is a core. And see here, thin laminations I'm going to show you. These are the thin laminations. All these thin laminations are isolated with an isolated material. So how we form a core? This is a core actually made up of a thin lamination. Next we go for part of windings or coils. So what are all windings and coils? Windings or coils. Windings are wound over the limbs of core like this. This is a core. This is primary winding. There are windings. This is primary winding. And this one is secondary winding. Because we are going to give power supply to this winding, so this is called as a primary winding. And which one is connected to the load? It is secondary winding. What is the job of this winding? Let's see. Windings are carries electric current that passes through this winding. Here we are going to give AC supply. This electric current passes through primary windings. So we need a material with less resistivity. So windings are made up of copper. Here, so we are using copper as a copper material for windings. And this copper wire is wounded to the limbs of magnetic core. There are many number of windings. So there is a risk of touching. You see here there are so many number of windings are there. There is a lot of risk in touching two subsequent turns. Here these two turns will touch each other. So there is a risk might be happened. So we are going to avoid this with the help of an insulation. So remember, these windings are insulated from each other by an insulation material such as varnish, etc. Since there is a length area of cross section, and see here here already some length area of cross section, as well as some resistivity of the material. Every material has its own resistivity. So there will be some resistance at the primary as well as the secondary windings. So current is passes through the first resistance, gives rises to some I square R losses, which losses are also called as copper losses. Here in this, since there is a length area of cross section and some resistivity of the material, it will be some resistance at the primary as well as secondary. So the current passes from first resistance, gives rises to I square R losses. I square R losses are also called as copper losses. These losses are also called as copper losses. Based on this arrangement of core windings, there are two types of transformers are there. Based upon windings and core material which we are going to use, there are two types of transformers are there. Core type transformer and second one shell type transformer. Let's see core type transformer. In this core type transformer, transformer is like this. This is a core. In this transformer, this is like this. See, here core is inside. Here there is a core inside. Here single magnetic circuit is there. Here only it forms a single magnetic circuit. Core is surrounded by windings or windings encircles the core. Here this is called core type transformer. Core type transformer is nothing but the windings encircles the core or core is surrounded by windings. Next, shell type transformers. Shell type transformers. Here, see, let's see the shell type transformer. This type of transformer here two magnetic circuits were formed. This is a core. So here core encircles the windings, or in other words we can say windings are surrounded by core. Here, core-type transformers windings encircles the core, but in shell-type transformer, the core encircles the windings. This is the major difference between two types of transformer. In core-type transformer, only single magnetic circuit was formed. In shell-type transformer, two magnetic circuits were formed. In this, we see about both in first magnetic circuits, one in first magnetic circuit and two in second magnetic circuits. Based on the arrangements of core and windings, the transformers are classified. Thank you for watching.